Okay, today we're gonna explain the concept typically used in chemistry referred to as a mole. Okay, this is a word that is used quite frequently when dealing with atoms and molecules, which are usually very, very, very small. Always are very small. This word actually means a number and is similar to a word that we're much more familiar with in daily life, and that is called dozen. Okay, so we use this word a lot. We use it for things like bananas, right? Or roses, right? Dozen roses, dozen eggs. So in daily life, for things that are objects that we're familiar with and are significant in size and mass, we, instead of saying 12, we just like to use the word dozen, right? Dozen means 12, okay? Just like that, when dealing with very, very small objects like atoms and molecules, we use the word mole, okay? And mole, just like dozen means 12, mole means nothing but a very specific number. That number is 6.022 times 10 to the power of 23, okay? Which is a huge number. If you move this decimal to the right 23 spaces, you get a huge, huge, huge number. It's like billions of billions of billions, right? Why do we use that number? Well, because atoms and molecules are really small. So you need a lot of them to make any reasonable calculation in terms of mass, in terms of volume, whatever, right? So a mole means this number. That's all there is to it. Now, the way I like to think of it is mole actually rhymes with bowl, right? So imagine that you have a bowl, okay, that's always the same size, and it always fits the same number of molecules and atoms, okay? Always the same size. One bowl fits these many atoms in it, okay? This number actually has a name. It's called Avogadro's number, okay? Avogadro's number, okay? Or sometimes referred simply as L, okay? But this number is how many atoms or molecules fit into this imaginary bowl. And again, I like thinking of bowl because it rhymes with mole, and also it's like one specific thing that has a certain number of these atoms inside of it, right? So imagine this bowl always carries the same number of atoms or molecules, whatever you're dealing with, in it, okay? So why do I say atoms or molecules? Because this number, this mole concept, can actually be applied to both atoms. For instance, if we're talking about gold or lithium, even oxygen, it doesn't matter. These are atoms or elements, right? And can also be used for molecules. What's a molecule? For instance, water, H2O, which is made up of one oxygen and two hydrogen. They're bound together, and together they make this one molecule. So if you were to say that you have one mole, or bowl, if you will, of water molecules, you would have these many molecules of water inside of that bowl, okay? Now, as you can imagine, some atoms or some elements have more mass than others, right? If you think about it under the influence of gravity, one weighs more than the other. Oxygen weighs less than gold. So gold actually has much more mass. So in these types of calculations, when they give you problems, they need to let you know how much one mole of a certain element or of a certain molecule weighs, right? So they're telling you, if I have one bowl full of these molecules or these atoms, it weighs this much. It has this much mass, right? They have to tell you that in order for you to do calculations. So, for instance, if they ask you how many moles are in 15 grams of lithium, right? You're missing some information. You know, you need to find out how many moles you have, or basically how many of these bowls you can fill up, right? Based on whatever they're giving you. So you have 15 grams of lithium, okay? But what I need to calculate is how many moles this corresponds to. So they need to tell me more information. In this case, in this type of problem, they would give you something like 1 mole of lithium actually has a mass of 6.94 grams per mole. Okay, so basically if you imagine a bowl full of lithium, right? A bowl that fits 1 mole, right? It would weigh or have a mass of 6.94 grams, 1 mole, right? But they're not telling you that you have that. They're telling you have actually 15 grams of lithium. So how much does it correspond to? There's different ways of doing this. The easiest way is using what we call a rule of 3, right? So basically, if 1 mole has a mass of 6.94 grams, right? How many moles would I have if I had 15 grams of the same stuff? Okay, this is what we call a rule of 3. So here, we need to think about separating this so we can figure out the rule of 3. Okay, the result in the end is going to be mole because we're looking for something called mole. So what we need to do here is say, take this and create a rule of 3. So 1 over x equals 6.94 over 15, right? And now we solve for x. How do we do that? We take the 15 and put it up here, and we take the x and put it up here. So basically crisscross. And so what that gives us is 1 times 15 equals 6.94 times x. Okay? But now we're solving for x, so we need to divide by 6.94 to leave x by itself, which leaves us 1 times 15 divided by 6.94 equals x. Okay? And this will give us how many moles we have. So the end result of this problem is x equals 15 divided by 6.94, which is right about 2.1614. And if we round up to this decimal, that's about 2.2 moles. So the easiest way to solve these, typically, as they give you the information, is just use a simple rule of 3. 1 mole, they're telling you 1 mole of lithium is this much. How many moles is this much? You extract the number so you can do the rule of 3, solve for x, and that gives you your result.